Hello, AP Calculus BC. Guess what? It is Friday for us as we're doing this lesson. That means the weekend is almost here. This may be the longest 3 days of my life. Not that I haven't enjoyed speaking and teaching and interacting with students, but the idea of having block day after block day after block day it's just a different feeling. So anyways, I'm excited to talk to you about 2.3 right now. And it actually goes pretty quick. I know teachers always say that, but it really does. Here's what we got. We got limits. I'm going to show you a little bit different way from doing it other than using that chart where you have to use your graphing calculator to plug in all these little values and getting outputs and then seeing if the outputs approach the same value from each direction. These go much more quickly, all right, which is why I think I like this better. 3 rules, okay, as you look at these, write them down. The limit as x approaches c of b, what does that equal to? Now, don't make this more confusing than what it is. If I just make this graph, okay, and let's say I graph b. Now, b is just a letter, which means it's just a constant. Okay, like a number, like 2, okay? All that means is we know it's going to be a horizontal line, okay? And maybe it's 2, maybe it's a little higher, we don't know. All I know is that it is horizontal, okay? If there's no x with it, it has to be horizontal, okay? Whereas c, well, I'll just make up c right there. And what is the limit as x approaches c from each direction? Well, it's the same thing as whatever b was, okay? It's whatever this line is. So I'm just going to write b. Okay, easy enough. What is the limit as x approaches c of x? Well, let me see if I can draw this and see if you can see it. Ooh, bad, sorry. Okay, so here's my graph. Sorry, that's not clean. And I'm not going to make this completely sendable-ish, but I'll draw blue here, NAU colors. And this is x, okay, so y is equal to x. And if I go at some c, I don't know what that is, okay, then what is this point going to be with respect to an output? Well, if I go from the left side and if I go from the right side, this is the identity matrix. So whatever x is, y is. So if this is c in this direction, it means you're also going up c, and that would be that respective answer. Cool. All right, the last thing is just a power. If you have x to the n and they're asking what happens as x goes to c, you're just going to have c inputted in there to the n power. Okay, so keep those in mind. Okay, those are just kind of little evaluation instruments that make this work a little bit easier. You don't have to draw this or you don't have to draw that. If you have those memorized, then they go super quick. See? Told you. Okay, now other ones. These only make sense if you look at the directions. Okay, so I'm going to put this in blue. And all it says is the limit as x approaches c for f of x is equal to L. So they're giving you an answer here. They're calling it L. And the limit as x approaches c, it's the same limits, okay, for g of x is equal to k. So they're giving you the answer to this. They're calling that k. Maybe I'll color that different for now. Harry colors. Okay, so here's what they got. The limit as x approaches c, that's what I have for each of those, no big deal. Of f of x, well, I already know what this is. This is L, okay? Which means you have this b out in front of it, okay? That's what a scalar is. Scalar is when you take a number and you multiply it in the front, kind of like a coefficient, okay? Except that you're dealing with a whole function instead. So in the end, all you're going to do is take the answer that you had for this f of x, which is L, and put the scalar, which is b, out in front of it. Okay. Done. All right. We know what the limit as x approaches c is for both f of x and g of x. This is L. And for g of x, it is k. And all you're going to do is write those answers just like you had before and put the operation that you see in between it. So plus or minus. That's it. All right, same thing for multiplication. Again, we have the same c value that you're taking the limit to as they are in these directions. and you're just going to write the answers to those, L and K, and in this case, you multiply them. No big deal. And this is going to be the same thing for division. Okay, so this would be L over K. Okay, and the last one, the limit as x approaches c of f of x all the n power, kind of matches what you saw on the previous page. It's going to give you a, let's see, f of x is equal to L. So as you take that limit, so it'll be L all to that n power. This may be our quickest lesson yet. Let's keep going. All right. Now, find the limits. This is what most of your questions will look like, okay? And you don't have to do the chart anymore. You always can, but you don't have to. They're not designed that way, okay? All right, now, here's the deal. If you know that this is a continuous function, okay, which it is, and we'll talk more about continuity in a little bit, probably next section. I know this is a parabola. Okay, I don't know where it is on the graph, but I just know it is a parabola that goes upwards because I have a squared term that is my highest power. And I know it goes up because my coefficient for that is a 3, which is also positive. Okay. Now, I don't know where 2 is. Maybe 2 is right here with respect to x. But as you go from the left and from the right, in order to figure out what this value is with respect to y, all you're going to do is plug it in. Like, well, that's pretty cool. Okay, now, do you have to show this work? Yes, okay. However, once you set it up, just plug the answer in your graphing calculator and you're done. So I know, just because I have to do this in my head, 2 times 2 is 4, times 3 is 12, minus 8 plus 1. 4 plus 1 is 5. Hopefully I did my math right. Okay, I need to see this and I need to see your answer. I don't need to see a middle step. Okay, great. Now, here, I'm hoping you're noticing, you're like, dang, rational function. I know x cannot equal -1, okay? And usually we have to find limits to that, but notice this. It's not -1 here. They just want you to evaluate at 1. So there actually may be at -1 some asymptote, okay? But in the end, the part that you're looking at over on the right side at 1 is continuous there. So you can still find the limit at that location, okay? So what we'll do is we'll just plug stuff in. Let's see, 1 squared plus 4 times 1 plus 5 all over 1 plus 1. Okay, I'm going to give you a little secret, which is kind of good and kind of bad. On an AP test, if you write your answer like this and you're like, I don't want to do anymore, you will still get full points. Okay, I will repeat this a lot throughout the year, but you do not have to simplify your arithmetic. Okay, so if you leave this like this, you get all the points. And that bothers people who are like, I just feel it's incomplete. And I know what you're saying, okay? In the back of the book, it'll give you what should be the right answer. But in the end, on an AP test, if this is your question and you wrote this as your answer for a free response question, you get all the points. Promise you. Okay. All right, next one, cosine of 2x. Okay, now I'm going to put some parentheses around here. Okay, and I'm going to treat it just like the other ones. I'm going to plug in 2 times, I almost put less of that, pi over 3. And again, I know this will work because a cosine curve just looks like this. It just keeps going and going and going, and that pi over 3, well, here's pi over 2. I know that there's no holes or asymptotes or anything like that. So I know there's going to be some limit there. Okay, I just want to know what it is. How far down do we have to go to get to that spot? So this is the cosine of, geez, let's multiply that together, 2 pi over 3. Okay, now, before I move further, some of you are like, I hate radians, and I do too, okay? But in calculus, you do not ever use degrees, all right? So you'll always use radian mode, okay? That doesn't mean I can't cheat and figure out this answer using degrees. However, they will never represent their answer in degrees in a problem or in an answer, okay? So kind of keep that in mind. All right, 2 pi over 3. Sometimes it's easier to figure out how many degrees that is, and I'm going to cheat a little bit. That is 180 over pi. And so sometimes that makes this easier when you're doing unit circle. I know that some of you have this unit circle memorized, okay? And that's great if you do, and if you don't, no big deal. This is 120 degrees, which is in quadrant 2. Okay. That means this is 60. And if you're going to fill in the sides of your right triangle using a unit circle, this side is the square root of 3, this side is 1, and this side is 2. Okay. Make sure you fill in the appropriate negatives. Okay. First of all, your hypotenuse will never be negative. It's always positive. I'm going up here, okay, the more positive direction, so this is a positive. And then from the origin, I'm going in a negative direction here, so that will be a negative. And so in the ends, I just have to take the cosine of what's represented by the angle from the origin. And cosine is adjacent or hypotenuse, so negative 1/2. Trigonometry doesn't go away, okay? All right, got a couple more here. X is going to 2. I need to find that limit. And notice what happens when you plug in 2. You're like, oh no, you get a 0, which you can't have. And if you plug it on the top, okay, you also get 0. Okay, so it ends up getting 0 over 0. And you're like, can I write that as an answer? And the answer is better not. Okay. So here's some things you have to consider. When you see stuff like this and it takes you back to Algebra 1, any thoughts come to your head as to maybe what you can do? You're right. You can factor it. And I'm going to give you a little hint here. And it doesn't always work this way, but sometimes they design the top of these in such a way that when you factor it, the bottom is one of those two answers, okay? Or one of those two pieces, one of the two factors. And so if I think of numbers that multiply to give me 8, 2 and 4 do work. In fact, 2 and 4 with subtraction signs in there do give you a negative 6x when you add those, okay? A negative 2 and a negative 4. So, and the nice thing is that these will go away. Okay? That's what happens when you multiply, okay? You can do those factors and they can cancel. Okay, and so all you're left with is x minus 4, and then you're going to plug that in. Plug in 2 there. 2 minus 4 is equal to negative 2. You're done. But you have to factor first. If you don't factor, bad things happen. Okay, people are like, why didn't you do that here? Well, tell me how this factors. I'll let you think about it. Okay. All right, got 2 left. Here's 5. Oh, it doesn't factor. Like, yes, it does. It doesn't. Trust me. What the heck? All right. This is my excellent Sun Devil cup here. And what I want you to notice is that it will change from Sparky to ASU. I don't know if you can see that. It's not the cup that does that. It's my Jedi Reflex that does that. Okay, only a few of us have that skill. All right, this one here. Again, if you plug in 3 like you did on the other ones, you get, well, 3 on the bottom. You already know this is a deal breaker. Could be undefined, but it's only if it's 0 on the denominator. If the top is a regular number, then you can say it's just not defined. But when you plug in 3 on the top, you get 3 plus 1 minus 2, which is 4 square rooted 2 minus 0 over 0. Okay, so like, what the heck do you do for this? And this is a very unorthodox problem. However, when you see these square roots, I'm just recopying it for now. Okay, here's what you're gonna do. Got bug on my screen, sorry. Okay, I'm gonna do this in purple. Okay, so here's what you're gonna do. The part that's ugly, would we all agree is this top piece? Yes, Rothery it is. Okay, so here's what I'm gonna do. I'm gonna multiply this by 1. When you multiply by 1, it does not change this expression. Is that true? Right, okay, so, and I'm gonna multiply by 1 in the form of a fraction. And as long as I make the top and the bottom the same expression, then that is equal to 1, which means it will not change it overall. So here's what I'm gonna do. I'm gonna recopy this. Okay. However, I'm going to change something. Instead of having a subtraction sign, I'm going to put the reverse. I'm going to put the addition sign. And then whatever I write on the top, I'm also going to write on the bottom. Because this is 1. Anything over itself. Agreed? Good. Okay. Now here's what I'm going to do. This will not feel comfortable for you at first, but you'll have to trust me on it. The bottom piece, I'm not going to do any math for. I'm just going to rewrite it. Okay, and this is square root of x plus 1 plus 2. Put that guy in parentheses, and I'm not going to touch it. Okay, I'm just going to leave that as is for as uncomfortable and as ugly as that looks. Okay, now here's what you'll notice about the top. These are binomials, each that look the same but have different signs. So imagine if I had this, x plus 2 and x minus 2. And if I said to multiply those, okay, some of you know the trick for this. You're like, well, they're binomials that look the same, which means your middle terms will cancel out. So I'll just square the first 2, I'll square the last 2, meaning square 2 squared. Sorry, square the 2, 2 squared is 4, and then you write a subtraction sign. Same deal here. I'm going to multiply the first terms together, and the square root times another square root, as long as they're the same inside pieces, is just going to be what you see, x plus 1 in the inside. Any square root multiplied by itself is just the inner piece, okay? And then again, I'm going to put a minus sign, and then I'm going to do the outer pieces, okay, the back pieces, okay, just like I did there. 2 times 2 is 4. Now you're like, Rothery, that does not feel any better. Sorry. It will in just a second. Okay. Notice I'm rewriting the denominator. Okay. And then the numerator, let's simplify. I guess I could. You can simplify the plus 1 and the minus 4, so that is x minus 3. Oh, will they always do that, Rothery? They will, okay? Well, they make them do that. So what I'm allowed to do is I can now cancel these. That's why I did not have you do any mess with that, any type of messy work with that. So, all right, so on the bottom, I'm left with the square root of x plus 1 plus 2. Oh, why did I put the equal to sign there? Huh. All over, well, if that disappeared, I'm just going to put a 1 there. Okay. And again, this was the limit as x goes to 3, and now you can plug in 3. Okay. And I'll say again, if this is an AP test, you can just leave it this way. Okay. But it will feel uncomfortable, so you'd really write 1 over the square root of 3 plus 1 is 4. Square root of 4 is 2 plus 2, which is 1/4. Cool. All right, one left on this. And again, just like before, if I were to plug in 0, 0 squared over 0 squared plus 3 times 0 cubed, and that's still 0 over 0, and I don't like that. Dang it. Like, dang, one more page? Actually, that last page is easy. So here's what you're going to do. Like anything else, if things don't work out right in the beginning, I am going to factor. Now, the top has nothing to factor, but what about the bottom? Do they have anything in common? Yes, x squared. And so if I pull an x squared out of there, I got 1. And if I pull an x squared out of there, I got 3 still, and an x. Okay. And what do you notice? Just like before, when you factor something out, something special is going to happen. Okay. And so these x squares will go away, and you got 1 over 1 plus 3x. And then you just plug in 0. Okay. And again, you could really leave it like this on an AP test. But 1 over 1 plus 3 times 0 This bottom piece just gives you a 1. So answer is 1. Dang. Where's my 1? There it is. All right. Do you guys show all this work? You do. All right. Maybe a thing that I didn't do super good. I thought I was going to have to put a limit there, but I don't have to. Once you plug in numbers, you don't have to write the limit piece, okay? So you'll notice like, hey, you wrote it in here, you wrote it in here. I did, but once you plug in numbers, you can stop writing that. All right, these are special rules, okay? If you were to graph sine of x over x, okay, I'm just going to draw this, in your graphing calculator, and make sure that your calculator is in radian mode, okay? Let me say that again. Put your calculator in radian mode and you probably will never change it, okay, for the entire year. Okay, so take it out of degree mode, put it in radian. And when you graph it, you get something that looks kind of like this. Okay, and what you'll find is, as x approaches 0 from the left and from the right, they both approach the same height, which is actually 1. Okay, and so you got to know that by rule, like it's like pi r squared, okay, like those types of things. Similarly, 1 minus cosine x over x, as x approaches 0, is 0. Okay. And then finally, this is a form of, gosh, it's a p times 1 plus to the nt. This is like your r, if that makes sense. But it's a form of a exponential, okay, exponential growth, which involves, okay, something that's more continuous, and this turns out to be a continuous function as these both go to 0, okay. So this will actually go to e, okay. So know what that looks like, okay. Now, when am I going to look at the know this? Well, this follows the scalar. Okay, and so I can move the 4 out front if I wanted. I don't need you to do this. You can just kind of answer this as you see it. But remember, this whole piece is 1. So you got 4 times 1, which is 4. Same thing here. This isn't quite like that, but I can sure make it look like it by doing a little factoring, by pulling out a 6. Okay, now this piece gives me 0. And you're like, well, that's no fun because the 6 over 6 went away. More bugs, sorry. The lights. You're getting bringing bugs here. It's not because I didn't shower. Tuesday was my shower day. I'm still feeling pretty fresh. Okay. All right, last one. Looks like this. It's the limit as x approaches 0. And here's what I'm going to do, if you don't mind. It kind of looks like this guy. Okay. And here's what you can do. Let's see. Let's play with this a little bit. This is really 1 over. Let me flip it around. Sine of x over x. Okay, so notice I'm flipping the reciprocal, but this is really the same thing. Imagine if I said this, 6 over 1, sorry, I'm going the other way. Just let me erase it. Okay. Imagine if I said 1 over 6. This is the same as 1 over, and watch me just put this in the denominator like I did here, but flip it. Okay, it's basically the same thing. It's kind of awkward. But what that does is it allows me to take the limit of each of these as x goes to 0. Okay, so remember that when you have just the b, okay, the limits as x approaches b, as in this case it's 0, it's just b. It's the same thing. So that means the top is going to be 1, and the bottom is this guy right here, is also 1. So your answer is 1. Okay. The slide before, I know this is the one that takes the most amount of time. okay? And that's where you're going to do most of your work. Try plugging things in. If they plug it in and you get something other than 0 over 0, then you are done, okay? If not, if you get that 0 over 0, that means you have to do some type of factoring, okay? Factor, cancel, and you'll get a result, okay? That is your homework, okay? It is on your note sheets. I don't think there's anything else I need to say. While I'm presenting this now, this is not going to be due for, I think, a couple days, all right? So it's not going to be due on Monday. I may, because I don't see you till Tuesday, I think. So it'll be due, I'll let you know when it's due. Okay. All right. Hope you have a good day. I'll talk to you soon. And a good weekend.